Welcome to Wildcat Science with Mrs. Haugo. This is Physical Science, Chapter 1 on Forces, and we are in 1.5, Sliding Friction, and this is Part 3. And today we are going to finish up our kitchen table science with this lab. So please make sure you have your lab open. If not, you want to pause the video and do that. Previously, in Part 2, we discussed the purpose, and we did our experiment where we had our friction box and we looked at the amount of friction, the force of friction to move it very slowly on the lab table, on the wide covered surface, the wide uncovered surface, and the narrow covered surface. So what we have left is the skinny or narrow uncovered surface. So let's do that now. So we have our skinny uncovered surface touching the table, and we have our spring scale, and keeping it parallel, the amount of friction is 0.1, 0.2. So 0.2 newtons. So you'll want to put that right there. And then we're going to move on to trial 2. Moving it very slowly, it is between 0.1 and 0.2, 0.2. So for trial 2, please write 0.2 newtons there, and then trial 3. It is again 0.2 newtons. So please write 0.2 newtons there, and moving on to our final trial. It's between 0.1 and 0.2, a little closer to 0.2. So again, 0.2. So for our average force, we're going to add 0.2, 0.2, 0.2, 0.2 together and divide by 4. And you can probably do that in your head. So coming down to our questions, starting with question 5. What is the force needed to keep the block moving at a constant speed on the skinny covered side? So I'll start you out. The force needed to keep the block moving at a constant speed on the skinny covered side is, and then you'll want to come up here to skinny covered and look at your average and make sure to put the unit newtons in there. Pause the video until you're done with Q5. And then we're going to move on to what will be Q6. What is the force needed to move the block, to keep the block moving at a constant speed on the skinny uncovered side? I'll start you out again. The force needed to keep the block moving at a constant speed on the skinny uncovered side is, and you'll want to come over to your average force for skinny uncovered and make sure you put newtons. And it's a complete sentence with a capital letter and a period. And purpose revisit. Does the force of friction depend on the area of contact between the block and the table? Explain using evidence. I'll start you out and then let's look at our data, our evidence. So the force of friction does or does not depend on the area of contact between the block and the table, period. The evidence for this is, so when we're looking at the area, we would look at, we're going to have to compare wide covered, or just the average, wide covered with skinny covered. And so were those closer, were those kind of close to each other? And then we're going to have to compare wide uncovered with skinny uncovered. And were those numbers kind of close to each other or really different. So when we look at wide covered versus skinny covered and wide uncovered versus skinny uncovered, again, the question you need to ask yourself is, are those numbers very close to each other or are they very different from each other? And so if they are pretty close to each other, then we will know that the area of surface does not make a difference for the force of friction, or the force of friction does not depend on the area of surface. But if the numbers are very different from each other, if wide versus skinny is very different from each other, then we would know that the force of friction does depend on the area of surface. So you'll want to write your answer and then explain using evidence from our lab. So make sure you use numbers and explain it in a high quality race statement, and then your lab will be done. So please check through that you have answered all of the questions, that they're written in complete sentences, capital letters, periods, that all of your numbers have units. And then when you have a wonderfully complete and beautiful lab, you'll want to turn that into Classroom. And that might be our last kitchen table science lab. So good job, everybody, and I will see you next time.